Hey everyone, today we are going to start looking at vectors. So as you can see from the title, this is just an introduction. We're going to get some vocabulary words and basic notation out of the way today. So first of all, definition. What is a vector? Well, a vector is a quantity that has both magnitude and direction. So let's write that in. Magnitude is just a fancy word for size, and direction. Okay, so geometrically, that is a vector right there, this right here. So it is represented using a directed line segment. So segment means that it's only a piece of a line. Notice how one side has a point and the other side has an arrow. This is important for vectors. So P, the side that just has the point, we call that the initial side, or I'm sorry, the initial point, or informally, they call that the tail. Q, the side that has the arrow, we call that the terminal point, or the tip. So one of the confusing things about vectors is its notation, because there's at least 3 different ways that I could think of that they represent vectors. So first off is the 2 points that are labeled here. So it started at point P, ended at point Q. So you could just represent a vector by writing those 2 letters, so PQ, with an arrow over the top. Okay? The second way is that they are normally labeled with a lowercase letter. So you see this, how it has a lowercase p. So you could just write the lowercase p also with an arrow on top. And then the third way, I didn't write it, I just went ahead and typed it here, is it's still a lowercase p, but it has to be in bold. So because I handwrite a lot of my notes, it's kind of hard to distinguish whether something's a regular P or if something is bold. So I'm more than likely not going to use that third type. I just wanted to include it because sometimes when I copy and paste my notes, this will show up. So just wanted to make you guys aware. More than likely, I'm going to use these 2 different types of notation. Okay, so next thing is, according to the definition, a vector has magnitude and direction. So let's first off, how would you find its magnitude? So it says, given a vector v, and see how it's lowercase bold, with an initial point at x1, y1, and a terminal point at x2, y2, the magnitude can be found using the distance formula. So this should look super familiar to you guys. I know you use it in geometry, you may even use it in some other classes, but it's just x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that entire thing. One thing I wanted to point out is, you see this here? So it's the letter V because that's our vector, but it has those double bars. Double bar is just a notation for magnitude. Okay, and then that definition right below, we're not going to do anything with it today, but it is something that's good to know. When I say 0 vector, I'm just talking about a vector that has a magnitude equal to 0. So basically, you wouldn't even be able to see it. So just so that we can practice a little bit, let's find the magnitude of this given vector. So we have the vector rs, and see how it has an arrow over the top, where r, the initial side, is at negative 310. So this is our x1 and y1. And its terminal point s is at x2, y2. Okay, so to solve this, I'm going to write rs with the arrow and then double bar to mean magnitude. I need a long square root. Okay, first we find the differences of the x's. So negative 3 minus 5 squared. And then you add the differences of the y. So 10 minus 6 squared. Now, I want to make sure I get this as exact as possible. So first thing I'm going to do is I'm only going to do the inside of the radical. So let me get a calculator here. Okay. So like I said, I'm not going to put the radical in just yet. I'm just going to do the inside. So parentheses, -3 minus 5 squared plus parentheses 10 minus 6 squared. And that gives me 80. Okay, so you always hope that it's going to be a perfect square. That way it can be a whole number. But as you guys know, 80 is not a perfect square. So, I mean, you could even test it if you weren't sure. So square root of 80. See that? Not a perfect square. So it's better if you simplify this radical. 80 is 16 times 5. So this would simplify to 4 square roots of 5. So that is the magnitude of the vector. Exactly 4 square roots of 5. And if you need, like if you just need an estimate, that's roughly 8.9. And I'm just getting that from here, from the calculator. Roughly 8.9. Let's use 4. So this vector is a little bit less than 9 units long. Just a little tiny bit less. Okay, so now let's move on to the next vocabulary thing. Standard position. So just like angles, vectors are said to be in standard position when their initial point is at the origin. So that's the important part. Initial point at the origin. So I probably should have included a picture here, but I didn't. So let me try to draw as best as I can. So we all know what the coordinate plane looks like. My x-axis and my y-axis. A vector, I'm going to use different colors. So let's use purple. A vector would start at the origin and then just kind of point outwards. So that's in standard position, not to be confused with an angle in standard position. So if it was an angle, it would have 2 sides. This is a vector, so only one piece. And let's say that terminal point that it's at, let's just call that AB, just so that we have something to refer to. So that purple vector is in standard position. Okay, so all vectors, we can write them in something called component form. So as long as it's in standard position, which my vector right there is, the component form of V is just that right there. So you have those pointy brackets, kind of looks like less than, greater than, but A comma B. So that's going to do some funny things to our formula. So for magnitude, remember it's x2 minus x1, but in this case, I have A minus 0. That would just stay A, so that's A squared. And then plus, same thing here, B minus 0 is still B squared. So it simplifies it a lot whenever it's in standard position. So honestly, anytime you have a vector, it's probably best to draw it in standard position, just so that you can simplify this magnitude formula. But another thing that we haven't really talked about that much yet is direction. I mean, that was part of the definition up here. It needs to have magnitude and direction. So how do we know what direction it's going in? Well, that's the direction angle. So if you can figure out what this angle is here, and we call that theta, that will tell you what direction that vector is pointing in. So in order to find that theta, all you need to do is tangent of theta equals B over A. Really, you want to isolate that theta, so let me do it over here. When you move tangent over to the other side, it becomes inverse. So truly, that's what you want to use. Okay, so this is the last example I have for today. It says find the magnitude and direction angle of the given vector. So we want to find both. And see, they already gave it to us in component form. So if you want to follow the little example from above, this would be A, this would be B. I know sometimes it helps to have a visual, so think of your coordinate plane. 8, that's positive, so it'd be this way. And then negative 12 means I'm going to go down. So that point is somewhere down here in quadrant 4. It's not to scale, but roughly just so you can get an idea. That's where that vector is at. So we need to find the length of that vector, just how far away it is from the origin. And we also need to find the angle. So I want to know what this angle is right here. Let me draw that better. What that theta is. That way I can know what direction this vector is pointing in. So let's start with the magnitude. So they gave this one a letter, it's letter A. So the magnitude of A, so I need to do double bars, is equal to the square roots of 8 squared plus negative 12 squared. Just like before, I'm going to start with only what's inside. 8 squared plus negative 12 squared. So that's 208. You always want to hope that that's a perfect square. I'm honestly not sure. Nope, it's not. So I need to simplify that. I know it's divisible by 4. It's divisible by 8. 16. I'm not sure. Yeah, it is. Okay, so that would simplify to 4 square roots of 13. And I'm not going to show my work on that, but I know you guys know how to simplify radicals. That is the magnitude of that vector, 4 square roots of 13. And if you're having a tough time picturing that, that's roughly 14.42. I'm just getting that from up here. So roughly it's about 14 and a half units long. Okay, but now I want to know the angle. Like how much did it go around to get to that location? So that's tangent. Theta is equal to negative 12 over 8. When you move the theta, when you move the tangent over, it becomes inverse. So we're just going to type this into the calculator and let's see what we get. Okay, so it gives me a negative number. That's weird. Negative 56.3. That doesn't mean that it's wrong. It's just kind of a weird number. So what they did is instead of going all the way around in the positive direction, they went the negative direction. They told me this part. So what did we just find it was? 56.3. They're telling me that that part is 56.3 degrees, or negative, because it's going in a negative direction. Like I said, that's not wrong. It is correct. It's just that we like positive numbers better. So how do I find out what that would be as a positive angle? So remember coterminal? It's exactly 360 degrees apart. So if I started at negative 56 and I went a full circle, that's 360. So I'm going to get that number. So I'm just going to put answer plus 360. So that's 303.7. To me, that makes a little bit more sense. So I'm going to write that down here, 303.7. Because it did go almost all the way around. So while that first one is not wrong, I just like the second one better. When y'all take a test, more than likely it's going to be a positive number. So just a heads up for that. Okay, guys, so that's really all the intro stuff that I wanted to show you. So you need to know the vocabulary. Magnitude means length. Direction is the angle that it's going in. Standard form or standard position means that it is starting at the origin. To calculate magnitude, it's the distance formula. To calculate the angle, you're going to use tangent. And remember that component form, as long as it starts at the origin, component form is just the terminal point. Alrighty, guys. So tomorrow we will go more in depth into vectors, and just let me know if you have any questions over anything. Bye.